I'm James, and I'll be doing our lab demonstration for SQL injection and cross-site scripting. Starting off, we have a simple website that is used to demonstrate our SQL injection. The website contains a single web page which is connected to an Access database. On the web page, we have a simple text box for user input, a button, and a data list which will return our results. Now once the user hits this button, it'll send whatever he types into that text box directly into the select statement. The text box input will not be verified, it will be immediately executed. So if we run this, we can see what that means. So let's give it a try. Type in someone's first name. Let's try Adam. And we get Adam's information. Now, since this website doesn't verify any of the user input, what we can do is type in a couple of special characters and modify that select statement. So what we're doing here is we're ending the select statement by putting in an apostrophe and adding in our own condition, which is or A equals A. Now, since this will always be true, that means the select statement will return all members. So if we run this, we indeed get everyone's information. Now we've used a pretty passive way to show this vulnerability. But another thing we can do is run another command, such as a drop command or update or delete or insert, and modify the actual database information. So we can do something a lot more destructive, say delete all the information in the members table. Now what we can do as the developer to mitigate this vulnerability is we can either use a different method of executing our SQL, which a lot of programming languages support, such as for this one we can use a access data source and create a parameter for our where condition, which would prevent the insertion of these apostrophes or insertion of additional commands. But what we're going to do here is do a simple input verification. So what we're going to do is check the first text box input for any apostrophe characters. And if our little condition returns true, if it does contain apostrophes, we want to return an error. Otherwise, we want to execute the select statement. So if we give this a try, let's try to execute our SQL injection attack, and instead of it executing, we get an error. Now let's check Adam just to make sure everything's working, and we have a safe way to input information. Now this isn't the best way to mitigate this vulnerability because there are other ways of getting a apostrophe into our website, such as using HTML encoding or alternate characters. So usually what you want to do as a developer is look into the programming languages that you are using and look for the best ways to execute those SQL conditions. But we won't go too deep into that. Now moving on, we're going to take a look at cross-site scripting. And what we have here is we have a virtual image of Windows Server 2003 running, and on it we have a program called Simple Web Server, which, as you can see here, is just a simple web page that says hello world, and it will also output whatever you put into the URL. Now this is called a URL handler, and it's used on many websites to take data directly from the URL and put it into the website to be handled. But what this means is that this is another avenue for attackers to attack your website. So what we're going to do is test out if this website is vulnerable by using this simple script from hackers.org, and we're going to type this directly into the URL and execute it. And it looks like we are indeed vulnerable to cross-site scripting. What you see here is a pop-up. Now this was executed from a piece of JavaScript, and that JavaScript came from a remote site, which was hackers.org. Now we've just verified that our site is vulnerable to cross-site scripting, so what we can do is use something a little more invasive and attack this website. So what we have is a keylogger, which is set up on our local machine. Our local machine is running a web server, so we can execute our scripts on remote websites. So I have a script prepared to attack the website with, and basically this is saying to execute our keylogger JavaScript from our local machine, which is the machine I'm on, and send that information to back to here, the local machine. And what we have is a small protocol listener, which is similar to netcap, and we're going to execute this script and see if we can attack this website. Alright, so we have the JavaScript running in the background. You can't see it as a regular user without looking at the source. So we're going to type in something into this text box which I've prepared and see if our keylogger captures it. And yes, indeed, it captured it. Not perfectly, but it did capture what we typed in here. So this means that this website is vulnerable to attacks. We can do attacks like this keylogger, or we can run denial of service attacks, or something to compromise the web server. Now the way to remediate this vulnerability is just like SQL injection. You want to validate all user input no matter where it's coming from, to include this URL handler and these text boxes that are within a lot of sites. So we don't want anything executing on our website that is coming from a user typing in something like script. We want to check all of our data inputs, and that is basically the key to preventing many attacks such as SQL injection, cross-site scripting, and say buffer overflows. And that is it for our lab demonstration.